Yes. Next coming to, in the before video we discussed about what is a matrix, right? What is a matrix and the types of matrices. In that types of matrices we have seen square matrix and some of the points for that related to that, right? Square matrix and what is called the principal diagonal, and sum of principal diagonal elements is called what? That all we have seen, right? So let us see now the second type of matrices. What is that matrix? Is diagonal matrix. Diagonal matrix. Let us take for this directly an example. Let it be by 2 0 0 0 minus 1 0 0 0 minus 1. Okay, if we take this example, what you observe here, what you observe, ma? Here observe the principal diagonal. The principal diagonal of this matrix only is given numbers. The remaining all elements are zeros. So if any matrix with the principal diagonal or numbers or letters and the remaining all zeros. Okay, remaining all zeros. Non-diagonal elements are zeros. Then we call this type of matrix as diagonal matrix. Diagonal matrix. Let us take one more example. Z is equal to 4 3 0 0 0 0 6 0 5. What you observe here? If a diagonal, we call a matrix as a diagonal matrix, then what it must be there, ma? The principal diagonal elements must be non-zero elements, and the remaining all elements, non-diagonal elements must be zero. But here what you observe, one element which is non-diagonal element is the non-zero number. So we can't call this as diagonal matrix. Whenever the principal diagonal elements are non-zero numbers and the remaining non-diagonal elements must be zeros, then only we can call as diagonal matrix. Okay. Next, third one, unit matrix. Unit matrix. Okay, unit matrix. For this also let us take one more example. That is P. Example P is 1 0 0 1. This is what is the, can you say what is the order of this matrix? Yes, it is 2 by 2 matrix. And what you observe here, the principal diagonal elements are ones and the remaining are non-zeros. Remaining are zeros. We call this type as unit matrix. Let us take one more example. U equal to 1 0 0 0 1 0 0 0 1. Okay. Here what you observe, the principal diagonal elements. The principal diagonal elements are all ones and non-diagonal elements are zeros. Okay. Like that it is there in any matrix. We call that matrix as unit matrix. Unit matrix. Next coming to fourth type, scalar matrix. Scalar matrix. Here in this example what we have seen, all the principal diagonal elements are ones. Okay, based on this let us take one more example, that is B minus 2 0 0 0 minus 2 0 0 0 minus 2. Same, this is also in the same this unit matrix mode, but in unit matrix the diagonal elements, the principal diagonal elements are ones. Okay, ones means same number. In the same way, if you have like the principal diagonal number, same numbers, that type of matrix is called as scalar matrix. Say for example, if I take one more matrix like this in this way, 3, 0, 0, 0, 5, 0, 0, 0, 2. If I took if I took a matrix in this way, the principal diagonal elements are non-zeros but are different numbers, right? But are different. But here what you observe, all the elements, diagonal elements are same. This type of matrices are called as scalar matrices. Okay, the principal diagonal elements are same. Okay, in that particular rows and columns are same. Then we call that matrix as scalar matrix. Okay. Next, coming to null matrix. Null matrix. Null matrix is nothing but all the elements in the matrix are zeros. The name itself specifies that null means nothing will be there. Okay, nothing will be there. But here we write zeros. Okay. So if a matrix has only zeros in its elements, as its elements, this type of matrices are called as null matrices. Okay. Next one is row matrix or column matrix. Row matrix or column matrix. If coming to row matrix, if you have only one row, then it is called as row matrix. If you coming to column matrix, you will have A, B, C. Only one column. Only one column. Okay. The type of matrix are called as row matrix and column matrix. Okay. Got it? These are the types of matrices. So, to identify the types of matrices, let me give some examples for your identity. Okay. So, first one, take a matrix that x is equals to 0, 1, 1, 1, 4, 3. Here, A, B, C. Okay. What you observe this here, what is the order of this matrix? That is 1, 2, 3 rows. That is 3 into 1, 2, 3. 3 columns. So this is called as square matrix. Okay. Next, say some P equal to 8, 0, 0, 0, 8, 0, 0, 0, 8. This is a square matrix with order 3 by 3, with order 3 by 3, and principal diagonal are non-zero and same. So what we call this as? Scalar matrix. Okay, and one more, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. This is also a square matrix. Whatever the examples we are taking here, mainly square matrices we are taking. Okay, this is of order what mark? This is of order 1, 2, 3, 4 rows. Means 4. Sorry, these are column size I ticked columns. So I write 4 columns. And first what we have to observe number of rows actually. Okay, this is first row, second row, third row and fourth row. So 4 by 4 means it's a square matrix, right? And what you observe in the principal diagonal, what you have? In the principal diagonal we are having only ones. Ones are there in the principal diagonal matrix. Principal diagonal. So what we call this as unit matrix. Got it? Yes. These are, and one more. Say for example, A, B, C, D, E, F. This is a border first. This is row 1. Only one row is there. So 1 into, here you are having many columns, that is 1, 2, 3, 4, 5 and 6. So 1 by 6. The order of this matrix is 1 by 6. But here you are having only one row. Specifically what that matrix is called as? Row matrix. Got it? These are some of the examples which makes you to easily understand the particular definitions or types of matrices. Okay? Thank you.